In this section, you are going to understand how to use matrices to solve simultaneous equations. So the first thing we need to do is to write the equation in this form: a x equals b, where A is the 2 by 2 matrix, which is 5, 1, 4, minus 2. That's A. And the X here is the matrix XY. And B here is 8, 5, the 2 by 1 matrix, 8, 5. Now the first thing we need to do is to find the determinant of A. So determinant A. So to find the determinant, we multiply products of the elements in the leading diagonal. So we have 5 times minus 2 minus the products of the elements in the non-leading, which is 4 times 1. So that gives us minus 10 minus 4, and that gives us minus 14. The next thing we need to do is to find the inverse of A. So because we're going to need that information, so A inverse was to 1 over the determinant, which is 1 over, we interchange the 2 by the 5 there, and then the elements in the non-leading diagonal, we multiply them by minus 1. So minus 1 times 4 gives us minus 4, and minus 1 times that 1 there gives us minus 1. Okay, so now that we have found the inverse of the matrix, we're going to use this information to solve for x and y. So what we're going to do is to multiply A inverse by our original matrix AX equals B. So in this case, I'm going to have A inverse times the original matrix here, which was A X. And on the right hand side, I multiply A inverse times B as well. And all we have to do now, because you know that an inverse times the matrix gives you the identity matrix. So in this case, this part is already solved. So A inverse is minus 1 over 14 times A, which is 5, 1, 4 minus 2 times xy there. On the right hand side now we multiply minus 1 over 14 there times minus 2 and B here is 8, 5. The left hand side, as I said, the inverse times the matrix gives us the identity matrix, which is 1, 0, 0, 1 times xy gives us the right hand side. So what we're going to do first is to multiply the row times the column, and then we use our factor after. So we have minus 1 over 14, and we're going to multiply out this, so it's the row, which is minus 2, 1 times the column 8, 5. So minus 8 times minus 2 gives us minus 16, plus 5 times minus 1 gives us minus 5, and then 8 times minus 4 gives us minus 32, plus 5 times 5 gives us positive 25. So what we have there is, this gives us really minus 1 over 14 times minus 21, and that gives us minus 7. And upon simplifying this, we get 1.5 minus 21 over 4, minus 21 times minus 1 over 14 gives us 21 over 14, which is 1.5, and then minus 7 times minus 1 over 14 there gives us just 7 over 14, which is 0.5. So it means that we have found the values of x and y. This is 0.5. So the left hand side here, the identity matrix 1001 times xy. 1001 behaves like the number 1 multiplied by xy. It has the property of 1. It's the same thing as multiplying 1 times xy really. And we get 1.5, 0.5. Which means that x equals 1.5 and y equals 0.5. So we have solved the simultaneous equation, which we can do a quick check. Since x is 1.5, we're going to have 5 times 1.5 plus y, which is 0.5, and that should give us 8, which is correct. Let's just try the other equation. So it's 4 times 1.5 minus 2 times 0.5, and that gives us 5 as well, which is correct. Thank you for listening, and I hope you do understand how to solve simultaneous equations using matrices method. The key thing you need to note is that you write the equation in this form: ax equals b, where A is a 2 by 2 matrix and x here is a vector xy, and B here is a vector 8, 5. Then what we do, we find the determinant, then the inverse. Then all we have to do is to use the inverse and multiply the original matrix. So when we multiply both sides by the inverse here, we get this. Upon simplifying this, we always get the identity matrix, which is 1001. And this 1001 here behaves like the number 1 times xy, and we get xy, x and y. And we work out the right hand side and we get the answer.